The world of medical technology is evolving at a rapid rate. Less than 130 years ago, the very first X-ray image was taken. But today, thanks to clever technology, there can be totally interactive and immersive 3D models of our bones and bodies created incredibly quickly. A business at the forefront of this technology is Perth-based Singular Health Group, and for more on what Singular offers is Managing Director and CEO Thomas Hanley. Thomas, thank you very much for joining me. So tell me, what exactly does Singular do?
So our software takes those two-dimensional CT and MRI scans and connects them and joins them in a way that you can then view that in totally immersive 3D and virtual reality. So from that, you're able to take something which is very, very difficult to see and understand if you haven't had a lot of radiological training, and get a better understanding of the pathology or the type of operation or the surgery that you're either about to go undertake or post-operatively when you're reviewing the kind of surgery that you've had done. So very, very important, because a lot of people see CT scans and MRI scans and have no idea what they're looking at.
And what does that mean for a surgeon who needs to do surgery?
So typically speaking, we'll have a surgeon, for example, that uses our technology in Switzerland. He's a neurosurgeon. He will use the VR or virtual reality to look at someone's brain and their head, inside their head, and work out the best angle of approach for the surgical operation they're about to undertake. But more importantly, as we move forward in the development of our technology, we've been able to work with organisations like the CSIRO and incorporate what we call artificial intelligence back into these models. So not only can you just visualise them, they will now go through and create computer-aided design models of the spine and the skull, which then lends itself to the ability to do projects like this, where a patient, for example, will present themselves with sleep apnea, and one of the more typical operations is to do an advancement of the jaw and the maxilla. And so once our software converts the skull from a DICOM file to a computer design file, the surgeon and the bioengineer are able to then cut or work out the cutting guides and the implants, like this, for example, in titanium, that will go through it and enable them to conduct that particular surgery. We have invested both in the software, and we've bought additional software that we're incorporating that will enable that surgical planning to occur, but we've also invested in which will be the largest 3D printing facility dedicated to the medical space in Australia, based in Melbourne.
Now, how does this change the outcome for the patient and indeed the process?
Sure. So at the moment, the process, for example, on an operation like this, is that the file will be sent to a multinational company, say, for example, in Belgium. That CT scan will be then converted into that file, usually takes about 3 hours. And then a number of surgeons will sit around a table at 6 o'clock in the afternoon. They'll bring on the surgeon or the bioengineer in Belgium, and they will work out a plan for that particular surgery, where the advancement is going to go, where the cuts are going to go. And then they will then go away and design these implants and guides, all in titanium, and then they'll send them to a 3D printing facility in Israel or in South Korea, and 6 weeks later, a box of both the biomodels and the implants and cutting guides will arrive on the surgeon's desk. What we're hoping to do, or what we will achieve, is that using these artificial intelligence algorithms and the ability to have local 3D printing, as it will take that from 6 weeks down to less than 2.
And better outcomes for patients?
We hope better outcomes for patients, because in a lot of cases, even after that 6-week turnaround process, there'll be mistakes inside that box, and so the whole process has to repeat itself again. So if you can undertake a surgery quicker, with more precision, and correct mistakes in a quicker turnaround, you always are going to get a better outcome for patients. But more importantly, when you then go back and look at post-operatively the surgery, either in VR or in 3D, what you're doing is you're educating the patient about the operation they've undertaken, and you're getting better buy-in about the kind of recovery process they need to do. So you're getting better, quicker recoveries by being able to inform patients and show them these DICOM files post-operatively of what they've gone through.
And no one's done this before?
Well, no, there are companies that go through and do parts of what we're doing through it, but in particular in terms of our DICOM viewing, 3D DICOM viewing, we will be the only company that provides that kind of software across Apple, Windows, and iOS. And that's really important because a lot of surgeons will work on a Mac at home, but on a Windows device at work. And if you don't have the same software that works across that, it does take up a lot of time. So having that consistent platform across all the different modalities is really important.
And you have an initiative that's known as Scan to Surgery.
Yeah.
What is that?
So scan to surgery is a bit what we talked before. So what will happen now is that a surgeon will specify an operation. They will get the CT scan done. So that's the scan. So that happens off to one side. The scan will and then they'll view the scan with the bioengineer. The bioengineer will then convert that into this sort of model. Whereas our scan to surgery approach combines all that into one software application. So that instead of it working separately, you're working collaboratively. The surgeon and the bioengineers are working collaboratively within the one piece of software.
Now, Singular Health only recently debuted on the ASX.
Yep.
So what can investors expect for the rest of this year?
We do have a number of releases of our software coming out this year. Obviously, the market is aware of the investment that we made in our 3D printing facility in Melbourne. So by August, September, we'll be 3D printing the biomodels in polymer and the titanium cutting guides, all here in Australia. So they can expect that this year. They can also expect that we'll be looking to make applications for FDA and TGA approval for both our algorithms and our software as we go forward the next few months.
And just finally, for investors who may be wondering, how are you going to monetize all of this?
So obviously, when it comes to 3D printing, that's an area of monetization right there. Our software is a software as a service model. If you then go as you're a doctor, you pay more and more, so you get up to a $30 a month package, which is sort of your professional surgical application. And then from that, when it comes to these planning tools, that's then another level above. And so all these are very simple, easy monthly charges that you get now in this sort of software as a service model, and that's really where the whole industry is moving towards.
So recurring revenue, and you see demand?
Well, we do. So the market's massive. The market's sort of $4.5 billion market globally. And this whole idea of personalised implants or care. So instead of getting currently you'd get, say, for example, a strip of titanium and you'd mould it by hand or you'd mould it into the face. This idea of 3D printing and coming up with the personalised care and personalised implants and cutting guides is a very, very big, fast-growing market, 20% per annum, $4.5 billion market.
Thank you so much, Thomas. That's Thomas Handley from Singular Health Group.
Thank you very much.
Thank you.